Welcome to the session. So today's topic for the lecture is the binary arithmetic using 1's complement. So by using 1's complement, we can perform the arithmetic operation. That means especially the subtraction. So myself, Suryawanshi, working as an assistant professor in the program Electronics Telecommunication Engineering in Walchand Institute of Technology, Solapur. So, which are the outcome of this session? At the end of the session, student will able to perform the operations on digital numbers. So, what should the knowledge you should possess before proceeding into the session? You should have a knowledge of a real number system, integer, decimal, and these things, and arithmetic operations on it. Arithmetic operations is the addition, subtractions on addition, subtraction, multiplication, division on a real number systems. So again, let's have a brief overview of the number systems. So number systems can be represented as integer part plus fraction part. So whatever is the left side to this dot is called as integer part, and what is right side of this dot is called as a fractional part. So every number system has that, and it also has a number of symbols in it. So if it is a decimal number system, it has a 10 symbols. If it is a binary number systems, it has a 2 symbols. If it is octal, then it is 8 symbol. Hexadecimal, it has a 16 symbols. So depending upon the number of symbols, the base is defined. So base may be the 2 for the binary, base may be the 10 for the decimal number system, and for the hexadecimal number system, base is the 16. Okay, so this is the summation for the integer part, and this is the summation for the fractional part. Okay, so any number systems can be represented by using this, and every numbers has a position. So in the integer part, this has a position of 0, this has a position of 1, and for the fractional part, this has a position of 1, that means -1, -2, -3, likewise. So -1, -2, -3, likewise. 0 is the the digit immediately before the dot point. Okay, so 0 is the position, 1 is the position, 3 or 2 is the position, 3, 4, 5, 6, and so on. So by that you can write the position also, and you can calculate weight of that particular position. So you can calculate the weight by using by the base also. So that means if the base is 10, so it is a 10 raised to 0 for the decimal number system. So 10 raised to 0 is a 1. So if that means and whatever is if the position is -1, and if it is a decimal number system, 10 raised to -1 is 0.1. So 10 raised to -2 is a 0.01. Similarly, 10 raised to 3 is a 1000. Okay, so depending upon that, you can have that position, and you can have the weight for that particular position by using this generalized way of representing the number system. So 1's complement. What is meant by the 1's complement? 1's complement means we are actually the swapping or changing the values. That means binary have only 2 values. So binary either it can take a 0, or it can take binary have a 2 states, that is 0 and 1. So by just by inverting, or just by changing 0 to the 1 and 1 and 0. So what that is, we can find the 1's complement of the given binary number. Okay. So actually the 1's complement, when you find the 1's complement of that given binary number, you are actually finding the negative equivalent of that number. So suppose the number is 1. So when you take its complement is 0, that means it is a negative equivalent of that 1. Suppose the binary number is 1 0, and its 1's complement is 0 1. So that is a 0. 1 0 is the binary equivalent of the number, that is that is 1, and when you take its complement, it will become a -1. Okay, so just by inverting the bits in the given binary numbers, that means the logical complement of that number, it will gives the 1's complement of that number. Also, you can find the 1's complement of the number by subtracting the 1 from it. So by subtracting every digit or every binary digits bits in the given binary number by 1. Okay, so this is way of finding the ones complement. So this is way of implementing finding the ones complement by with the help of the NOT gate. So for the 4-bit, you can find the 4-bit. You requires the 4 NOT gate. So for that, so just give that 4-bit input to the 4 NOT gates. You will get the ones complement of that 4-bit. Okay. So if the input is a 0 0 0 0, output is 1 1 1 1. If the input is 1 0 1 0, output is 0 1 0 1. So it just complementing that. So this is the implementation or finding the ones complement with the help of the hardware, that is NOT gate. So ones complement of some ones complements are given here. 0 0 0, ones complement is 1 1 1. The ones complement of the 0 0 1, it is 1 1 0. Ones complement of the 0 1 0, it is 1 0 1. Ones complement of the 0 1 1, it is 1 0 0. Ones complement of the 1 0 0, it is 0 1 1 1. So ones complement of 1 0 1, it is 0 1 0. Ones complement of 1 1 0, it is a 0 0 1. And ones complement of 1 1 1, so complementing all bits in it, so it will become a 0 0 0. So this is an example for the 3 bits, and similarly you can extend it to the 4-bit, 5-bit, 6-bit, 7-bit, 8-bit. It's up to you. So in this way you can find the ones complement. Now subtraction using a ones complement. So so as I said that ones complement actually finding the negative equivalent of that given number. So when you take a ones complement of the number, that means you are taking the negative equivalent of that number. So when you take a negative equivalent of the number, when you add that particular number to this from the number from which it is subtracted, then you'll get the subtraction operation by adding it. Okay, so in this way you can perform the subtraction operation by addition, by taking the ones complement. Then what you have to do, you have to take a ones complement of the subtrahend. Subtrahend means the number from which it is get subtracted. Okay, that number from which it is get subtracted, it is a subtrahend. So you have to add it with the minute from the it is subtracted. So first of all you have to take a ones complement, add with the minute, and if in this above addition, if there is a carry that suggests that the addition is, that particular addition is a positive, that means your result is a positive. So what you have to do with this carry, so you have to take that carry and add it to the least significant bit. Least significant bit is the rightmost bit in your given binary number, so you have to add that one. So you'll get the actual result of that actual value of the subtraction. So for that it suggests that if there is a carry, that means result is a positive. So subtraction operation, you are already aware about that. So when you subtract the lower number from the higher one, you will get the positive result, and when you subtract the higher number from the lower, you will get the negative result. So in this case, when you get the carry, that means you are getting the positive results. And if there is no carry, that means there is a result is a negative. That means you are subtracting the higher value from the lower value. So if you get that carry, so you have to take a ones complement of the result to find the magnitude of that answer. Means answer already you know it is a negative, and you have to take a ones complement of that result to find the magnitude of that result. So these are the examples you can have by using a ones complement. So these are the two numbers. So this number is to be subtracted from this by using ones complement. So what you have to do, you have to take a ones complement of this number. So ones complement of this number is this 0 0 0 1 0 1 is 1 1 0 1 0. So after taking ones complement, you have to add with this. So you'll get, when you add this, you will get the extra carry. So as you are getting the extra carry, that means your result is positive. That means you are subtracting the lower number from the higher number. So what you have to do with this carry, so you have to take this carry and add it to the least significant bit, rightmost bit of this binary number. So when you add this number to this, you will get the actual result, that is 1 0 0 1 0 0 0 0 4 times. Okay. So this is we often doing the subtraction using a ones complement. So can you multiply the two numbers using 1's complement? So think about it. If your answer is yes, then how will you do it? So you can pause this video, think about it. You can take a piece of a paper, write it on it if your answer is yes. Give the justification that you can multiply the two numbers by using 1's complement. And the answer is yes. So you can do the multiplication by successive addition operation, or a normal multiplication as you do follow in the decimal number system. So multiplication is also possible in the binary number system, octal number system, hexadecimal number system. So these are the references for this session. Thank you.